The project aims to analyze and resolve font rendering issues encountered during the development of micro SAS, post-to-video. It serves as a test environment to replicate specific failures related to broken emojis and fallback fonts observed in production, outlining the architectural changes implemented to address these challenges. Motivated by critical font rendering failures on Ubuntu production servers while using Puppeteer, which worked flawlessly on a Windows 11 machine. The project seeks to answer crucial design questions regarding the source of these issues, fixes for the rendering inconsistencies, and testing methods for maintaining uniform results. Key takeaways highlight that Linux may not recognize fonts directly, limiting Chromium's access to them without font config. It emphasizes the necessity of base64 encoding for fonts when using set content, the importance of awaiting document.fonts.ready for accurate screenshots, and notes how incorrect UTF-8 encoding can corrupt emoji rendering. The installation section outlines essential system dependencies, CI/CD setup, and initial project startup guidelines, which are critical for ensuring the correct functioning of the project's font rendering processes. This section discusses the need to verify system dependencies, particularly that Puppeteer's Chromium engine requires the libfontconfig1 library for font rendering. It explains how to check for the library's presence on Ubuntu droplets and provides a manual installation command if necessary. Focuses on ensuring the libfontconfig1 library is present on the production VPS before deployment. It details a GitHub Actions workflow edition that checks for the library and installs it if absent, preventing deployment failures related to font rendering. The project setup steps are outlined, where users must install Node.js dependencies and build the project. A smooth setup is vital to ensure all subsequent render tasks function correctly. To execute the rendering engine, a simple command for both development and production environments is provided. Running these commands generates images demonstrating the effectiveness of font rendering strategies using both GoTo and set content. Technologies used in the project include Windows 11 for local development and Ubuntu 24x for production, alongside Puppeteer Chromium for rendering, Node.js TypeScript for development, and GitHub Actions for CI/CD automation. The section emphasizes understanding the Linux font gap to solve rendering issues effectively, particularly the differences in behavior of Puppeteer on various OS platforms. Explains how Chromium on Linux relies on font config to find fonts, contrasting with Windows. If font config hasn't indexed a font, Chromium defaults to a generic fallback, leading to rendering issues even if the font file exists locally. Describes the sandbox in which Puppeteer operates, which restricts local file access. This means that if font config is unaware of a bundled font, Chromium cannot access it, complicating the rendering process. Discusses the synchronization issues in Puppeteer rendering that can lead to FOUT, flash of unstyled text. If a screenshot is taken while Chromium is loading fonts, it may capture fallback fonts instead, permanently affecting the final output. Identifies design challenges related to font rendering, including OS-level font availability, timing issues that can result in FOUT, and rendering parity between different systems, impacting the behavior of both GoTo and set content methods. This section introduces solutions to the design challenges outlined previously and explores the reasoning behind each chosen approach for addressing font rendering issues. Discusses two options to resolve OS-level font availability issues: install fonts at the OS level or bundle them in the project. The chosen approach is to bundle fonts for portability and to ensure the project remains self-contained. Presents options for registering new font assets, running font config update commands versus in-memory injection of fonts as base64 directly in HTML. A hybrid approach is recommended, adapting solutions for both methods based on their compatibility with Puppeteer's constraints. Recommends using the Web Font API to synchronize font loading and avoid FOUT, ensuring that rendering is accurate by waiting for font readiness before taking screenshots. Addresses pathing issues encountered when using set content, suggesting the use of base64 encoding to eliminate paths and potential case sensitivity errors between different operating systems. Identifies security challenges in headless environments related to local file access and suggests using data URIs to bypass these restrictions, enhancing reliability and security. Explains differences in rendering engines between Windows and Linux, proposing a CSS normalization strategy to ensure consistency in font rendering across platforms, leveraging GitHub Actions for verification. Outlines the project code structure, emphasizing modular organization, where each file is responsible for a specific aspect of the font rendering process. The index.ts file initializes the rendering processes sequentially with async functions calling render with goto and render with set content. This structure promotes clean execution order in rendering tasks. The Puppeteer renderengine.js file manages the core rendering logic, incorporating a function to run render tasks with strategies goto via set content. It emphasizes the execution of synchronization, capturing images, and error handling. This section details the rendering logic for the goto strategy and discusses how it manages file creation and cleanup while ensuring proper loading of HTML content through the generated file paths. Continues from the previous section, showcasing the rendering process for the set content strategy, where HTML is injected directly, focusing on the use of base 64 fonts to avoid path and origin issues. Defines a common HTML template in build.html.ts, including CSS normalization for rendering parity across different environments. The template also outlines how to properly load fonts. Splits the function to handle font loading based on the strategy being used, emphasizing the choice of method for both goto and set content, considering font registration rules. The utils.ts file contains functional tools needed for font management, including obtaining font paths and handling base 64 encoding. It offers critical functionality to support rendering requirements. Includes a utility function to wait for the fonts to be ready before continuing, which is critical to avoid FOUT issues during rendering and ensures high fidelity in output. Defines constants in constants.ts, specifically for CSS normalization that promotes consistent rendering quality across different systems, addressing various challenges encountered. This demo section provides visual proof of the successful installation of the libfontconfig1 library on a production droplet and demonstrates rendered outputs from the goto and set content methods, showcasing the project's effectiveness. Continues the demo with visual examples of rendered images created using the set content method, underlining successful implementation despite previous rendering challenges. Demonstrates a bad output scenario with broken emoji rendering in post to video, illustrating the pitfalls encountered during the initial development phase. Showcases the correctly rendered README, highlighting the project's functionality in dealing with emoji rendering issues compared to previous failures. Investigates the memory overhead of using base 64 encoding for fonts in rendering processes, stressing the importance of ensuring documents are fully loaded before capturing the output to avoid performance hits. Lists relevant references for further exploration on the topic, including links to a case study, Puppeteer troubleshooting documentation, and the MDN guide on font loading API, ensuring additional resources are available to readers.